Alright, so for this problem, I have 3 to the power of x plus 3 to the power of x plus 3 to the power of x is equal to 1. So to solve this, what I'm first going to do is for my left-hand side, I'm going to factor out 3 to the power of x. So now I have 3 to the power of x times, now 3 to the power of x divided by 3 to the power of x is 1, so I have 3 to the power of x times 1 plus 1 plus 1. This is equal to 1. Now, if I simplify this in the parentheses, I get 3 to the power of x times 3 is equal to 1. Now 3 here, this is the same thing as 3 to the power of 1. And if I have something in the form a to the power of m times a to the power of n, this is equal to a to the power of m plus n. So in this case, 3 to the power of x times 3 to the power of 1, that's going to equal 3 to the power of x plus 1, which is equal to 1. And 1 is the same thing as 3 to the power of 0, because anything to the power of 0 is equal to 1. So I have 3 to the power of x is equal to 3 to the power of 0. Now, if I have something in the form a to the power of m is equal to a to the power of n, this means that m is equal to n. So in this case, x plus 1 is equal to 0. So now to solve this, I'm going to subtract 1 on both sides, then these two cancel out, and I'll be left with x is equal to negative 1. So this is my answer. Now, I actually have a second method of solving this problem. So, again, I first start with 3 to the power of x plus 3 to the power of x plus 3 to the power of x is equal to 1. I factor out 3 to the power of x, so I get 3 to the power of x times 3 is equal to 1. However, now, instead of multiplying 3 to the power of x with 3, I'm actually going to divide both sides by 3. So now these two are going to cancel out, and I'll have 3 to the power of x is equal to 1 over 3. Now, if I have something in the form 1 over a to the power of n, this is simply equal to a to the power of negative n. So we can think of 3 in this case as 3 to the power of 1. So 1 over 3 to the power of 1, that's going to be the same thing as 3 to the power of negative 1. And remember, if I have something in the form a to the power of m is equal to a to the power of n, this means that m is equal to n. So in this case, x is equal to negative 1. So this is my answer again, using the second method. So now to check, I have 3 to the power of x plus 3 to the power of x plus 3 to the power of x is equal to 1. X is equal to negative 1, so I have 3 to the power of negative 1 plus 3 to the power of negative 1 plus 3 to the power of negative 1 is equal to 1. 3 to the power of negative 1 is the same thing as 1 over 3, so I have 1 over 3 plus 1 over 3 plus 1 over 3 is equal to 1. 1 over 3 plus 1 over 3 is 2 over 3. 2 over 3 plus 1 over 3 is 3 over 3, so I have 3 over 3 equals 1. 3 over 3 is 1, so I have 1 equals 1, and this is right, so my answer is right. Alright, so in this problem, I have x to the power of x is equal to 2 to the power of 2048. So now the first thing I'm going to do is I'm going to rewrite 2048 here as 1024 times 2. Now, if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So 2 to the power of 1024 times 2, I can rewrite as 2 to the power of 2 to the power of 1024. Now 2 to the power of 2, that's simply equal to 4. So now I have x to the power of x is equal to 4 to the power of 1024. And now 1024, remember how I rewrote 2048 1024 times 2. Now I'm going to rewrite 1024 as 512 times 2. So now I have 4 to the power of 512 times 2. And now I'm going to do the same thing. If I have something in the form a to the power of m times n, that's equal to a to the power of m to the power of n. So this is equal to 4 to the power of 2 to the power of 512. And 4 to the power of 2, that's simply equal to 16. So now I have x to the power of x is equal to 16 to the power of 512. And now I'm going to do this again. So now I have x to the power of x is equal to 16 to the power of 512. That's the same thing as 2 times 256. And again, this is equal to 16 to the power of 2 to the power of 256. and 16 to the power of 2, that's simply equal to 256. So now I have x to the power of x is equal to 256 to the power of 256. Now, if I have something in the form a to the power of a is equal to b to the power of b, then this means that a is equal to b. However, this is only true if b is greater than or equal to 1. So in this case, as you can see, a would be x and b would be 256. And is 256 greater than or equal to 1? Yes, it is. Meaning, we can write this in the form a equals b. So x is equal to 256. So this is my answer. Alright, so for this problem, I have x to the power of x is equal to x to the power of 2. So, to solve this, I'm going to first start by dividing both sides by x to the power of 2. So then these two cancel out, and now I'll be left with x to the power of x over x to the power of 2 is equal to 1. Now, if I have something in the form a to the power of m over a to the power of n, this is equal to a to the power of m minus n. So in this case, x to the power of x over x to the power of 2, can rewrite that as x to the power of x minus 2. And this is equal to 1. Now, if I take the natural log, or ln, on both sides, I get ln x to the power of x minus 2 is equal to ln 1. Now, if I have something in the form ln a to the power of b, I can actually move this x1 and b to the front. So this can equal b times ln a. So for ln x to the power of x minus 2, I can move x minus 2 to the front. So that's going to equal x minus 2 times ln x, which is equal to ln 1. Now ln 1 is simply equal to 0. So now I have x minus 2 times ln x is equal to 0. So this actually gives me two equations. I have x minus 2 is equal to 0, and I also have ln x is equal to 0. So for x minus 2 equals 0, all I have to do is add 2 on both sides, and I get x is equal to 2. So this is one solution of x. Now for ln x equals 0, I'm actually going to take e to the power of both sides. So now I have e to the power of ln x is equal to e to the power of 0. Now e and ln, these two simply cancel out. So for my left-hand side, all I'm simply left with is x is equal to e to the power of 0 is 1, because anything to the power of 0 is 1. So I have x equals 1. So these are my two solutions. So now to check, I had x to the power of x is equal to x to the power of 2. If x equals 2, I have 2 to the power of 2 equals 2 to the power of 2, meaning 4 equals 4, so this is right. So x equals 2 is right. Now if x equals 1, I have 1 to the power of 1 equals 1 to the power of 2, 1 to the power of 1 is 1, 1 to the power of 2 is 1, so this is right as well. Guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this algebraic equation. So we have x factorial is equal to 10 factorial over 6 factorial. Now, 10 factorial, this is equal to 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So it's equal to 10 multiplied by n minus 1 all the way up to 1. Now we are dividing this by 6 factorial, which is equal to 6 times 5 times 4 times 3 times 2 times 1. Now if you notice, We have 6 on our numerator as well as 6 on our denominator, so these two can cancel out. Same thing with 5, same thing with 4, and same thing with all the terms below 6. So now all we're left with is simply 10 times 9 times 8 times 7. And this is equal to x factorial. Now 10, this is equal to 5 times 2. 9 is equal to 3 times 3. 8 is equal to 4 times 2. And 7 is just 7. We can't simplify that anymore. Now, we want to find all the numbers from 2 going up. So we already have 2, right? So 2 times, so we could cancel that out. Now we have a 3, so write 3. Now we have a 4, we have a 5. Now we don't actually have a 6, however 3 times 2 is 6. So then these two cancel out, and finally we have a 7. So we could think of 1 times this, because 1 times anything is itself, and as you can see, this is equal to 7 factorial, because it's 7 times 7 minus 1 times 7 minus 2, going on until 1. So this means that x is equal to 7.